I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth, at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds, and against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer, when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most?
Picture this. You've won a membership to a space gym. You get to travel around the solar system and work out. But gravity changes on different space bodies. So let's find out if you can get stronger elsewhere or if you should keep practicing on Earth. Your spaceship is approaching dwarf planet Pluto. It's getting chillier by the second. No wonder! The sun is over 3.7 billion miles away. You must be glad you brought your thermal spacesuit along, right? To leave the spacecraft, Earthlings would need the help of a gravity machine, since gravity on Pluto is a mere 1/15th of that on Earth. Gravity is the force that pulls you toward the ground. The smaller the mass of a space body is, the weaker its gravity. So, on Pluto, you can't do any sports that involve running. If you did, you'd most likely fly away. You can try out elephant lifting, though. After all, you can't do it back on Earth. On Pluto, picking up an elephant weighing 2,000 pounds feels like lifting 120 pounds. The next stop is Neptune. It's over 30 times farther away from the Sun than Earth. The atmosphere there is dark and cold. You might get overwhelmed by the planet's gigantic size. It's called an ice giant for a reason. Maybe today you'll feel like doing some winter sports? To say Neptune exists in perpetual winter is an understatement. The average temperature on this planet is around minus 373 degrees Fahrenheit. But gravity here is only 10% stronger than that on Earth, so you don't feel much difference. This world doesn't have a solid surface, so you won't be able to leave the spacecraft. Is that an ice hockey rink I see? Grab your ice skates and your stick and get ready to outplay your fellow passengers. How about a quick pit stop on Uranus? This is another ice giant, and gravity here is 90% of that on Earth. You can do a few push-ups inside the spacecraft, as you won't be stepping outside. The slushy surface of the planet is made up of water, methane, and ammonia in its liquid form. There's no solid ground to walk on. But if you somehow found a way to go outside, you'd feel lighter than on Earth. If you weighed 100 pounds back home, it would be 90 pounds here. Can we call this a Uranian diet? When approaching Saturn, please mind its rings, which aren't actually rings. They consist of pieces of asteroids and meteors flying around the planet. Saturn's mass is so big that it attracts many other space bodies to its orbit. And right now, you're one of them. Time to get creative with your workout. You've scheduled a skydiving experience here. If you freefall in Saturn's atmosphere, you'll reach the speed of 30 miles per second. Don't forget to open your parachute. On second thought, though, you won't be able to touch the ground anyway. Saturn's surface is pure gas. Quick fun fact, once Saturn got in the way of the 10th planet forming in the solar system. The planet's debris, which partially makes up Saturn's rings now, could have blended into a planet, but it was pulled into Saturn's orbit instead. You're nearing Europa, one of Jupiter's moons. Gravity here is so weak you feel weightless. Let's say there's a rock climbing wall there. How about you give it a try? Usually, this sport requires a lot of physical strength. But here, you'll only have to carry 13% of your weight. Your climb to the top will be easy peasy in these conditions. Entering Jupiter's atmosphere will feel like being inside a cloud. See that red spot in the bottom left corner? That's a storm twice the size of Earth that's been raging for hundreds of years. To have some fun here, why don't you do some jumping jacks? I'll count to 100. Ready, set, go. Gravity here is super strong. It's 2.5 times as powerful as gravity on Earth, so you'll probably get exhausted at the count of 30. Too bad. Uh-oh. Passengers aboard the spacecraft, fasten your seatbelts. You might experience some heavy turbulence. To travel from Jupiter to Mars, you'll have to move through an asteroid belt. Just in case you're worried your ship will bump into something, relax, there's a distance of 300,000 miles between asteroids. Let's stop at Ceres, the only dwarf planet in the asteroid belt. Gravity here will make you feel pretty strong. How about practicing some caber tossing? Cabers are heavy logs that can measure up to 20 feet long. The goal is to throw them as far as possible. Here, a 180-pound pole feels as if it weighs 5 pounds, which is, basically, the weight of a melon. Ready for the Ceres caper competition? Woohoo! Finally, Mars. Remember all those handstands you've always wanted to try? Well, here's the place to do them. Mars's gravity is about 2.5 times weaker than that on Earth, which means you'll probably be able to lift your own body weight without any difficulty. Since people keep trying to terraform Mars, opening a gym here doesn't sound like a bad idea, does it? Passengers and crew members, we're now beginning our descent to Phobos. It's one of Mars's moons. Gravity here is incredibly weak. If you've always dreamed of having superhuman strength, this is the place for you. You can work out here by, say, doing some artistic gymnastics. Start off with a cartwheel, then move on to tricks performed in the air. On Phobos, you can start doing triple back handsprings in no time. Ah, look, Earth is about to appear on the horizon. It sure looks majestic from here, but we won't stop there now. Instead, let's visit Earth's sister, Venus. It has almost the same mass as Earth, which means these planets have similar gravities. Now, Earthlings can't survive on Venus's surface because of the large amount of ammonia in its atmosphere. But let's imagine you could practice some outdoor sports there. Do you feel like trying bumper bubble soccer? That's when you dress yourself in a giant bubble ball vest and keep bumping into other players. People play this game on Earth. On Venus, with its slightly weaker gravity, it might be a little bit easier. But still, you have to consider you'll be wearing a 25-pound ball as a vest, kind of like a hamster back on Earth. Not to mention your outfit will restrict your arms and legs. It's a challenge, but it sounds fun to me. Moving on, if you land on the sunny side of Mercury, you'll experience scalding hot temperatures of 800 degrees Fahrenheit. If you're feeling tired after your space workout, a relaxing, steamy sauna will be just the thing. You'll feel like a brand new person by the time you arrive on the next planet. We'll fly as close to the Sun as we can so that you can have a taste of its gravity. The Sun's mass is huge. It's over 333,000 times the mass of Earth. And gravity here is extremely powerful. You'd have trouble lifting something as light as a bottle of water if you managed to step on the surface of the Sun. Too hot, you say? Well, I imagine it's a whole lot cooler if you come back at night. Haha, just kidding. On our way back home, we'll stop by the Moon. I mean, our Earth's natural satellite. Walking on the surface of the Moon will feel like jumping. You'll be able to jump as far as 33 feet, so why not try some parkour? If you play basketball, scoring a point will be very difficult. But then you can jump higher than the hoop and do an epic slam dunk. And how about baseball? If you throw the ball upward, you'll probably never see it again. Finally, we land on Earth. Sorry to disappoint you, but you're not coming back with any superhuman strength. Even when you were lifting an elephant, gravity was helping you out a lot. It was a good trip, though. Don't you think so? Okay, picture this. In the not-too-distant future, you're heading out on a space vacation, and you need to decide which items are worth bringing along. But instead of checking the weather forecast, you open a gravity simulator. That's because you need to know how each object will behave on different planets. For instance, should you take this metal shovel with you or not? Well, according to your itinerary, it's going to be a long trip. You're planning to visit every planet in the solar system and even a few moons. But due to the difference in gravity on these space bodies, you're not sure how useful some of the objects you're going to bring along will be. Well, let's start with the basics. Tupperware. I don't know about other space travelers, but us Earthlings carry our Tupperware around everywhere we go. And still, if you were to transport it to, let's say Mercury, it would most likely fly away into the atmosphere. These plastic containers you use to keep your food are too light. And since the gravity on Mercury is 2.5 times weaker as gravity on Earth, well, maybe you'll have to fill your plastic containers up before taking them out of your spaceship to have a picnic. If a Tupperware container weighs about 0.5 pound on Earth, it'll weigh just 1/4 of that on Mercury. Now, if we add some bananas, a handful of baby carrots, and 2 watermelons, then it'll be safe to carry it out of your space vehicle. You'll just have some difficulty making it all fit in a standard-sized container. But wait! Before you do that, you should know that the atmospheric temperature on Mercury can reach up to 800 degrees Fahrenheit. This means that any plastic container will instantly melt as soon as it gets in contact with the air. It'll burn up all the food, too. You can probably try taking a titanium container, that will work, or just stick to astronaut food. Now, shall we say Venus? Okay, Venus. If you were to take the same empty container to Venus, it would behave similarly to how it does on Earth. This is because Venus is also known as our planet's twin. These two have much in common. For example, almost the same size and mass. And when the topic is gravity, the formula goes like this. The bigger the mass and the greater the density, the stronger the gravity. Venus's gravity is approximately 10% weaker than Earth's. So, yes, you may leave your spaceship with your container, empty or full, and enjoy a beautiful and scenic lunch on the surface of Venus. Now, you'll have to figure out a way to eat without taking your spacesuit off, though. The atmosphere of Venus is filled with sulfuric acid, which can irritate your nose and throat and cause difficulties in breathing. Or worse. Much worse. Now, you'll have to forget about taking anything too light outside on Phobos. A little hint for you, it's not a Greek island, not even Greek yogurt, although it's a cool name. It's actually one of Mars's moons. Here, even your spacecraft would need a little extra help to keep close to the ground. If it weighed as much as a school bus, any regular-sized person could pick it up with just one hand. This is because on Phobos, the inhabitants of Earth barely feel the weight of gravity, And be very careful when jumping around because one leap and you may fly straight into outer space.
Passengers on board the Voyager spaceship, please keep your arms and legs inside the vehicle at all times.
Well, you're approaching Jupiter, a gas giant. A never-ending storm is raging in its atmosphere. Plus, there's no solid surface there, which means no landing for you on this planet. If you look out the window, it might seem that you are moving through a giant cloud. But for the purpose of your experiment, it'll work just fine. Try throwing into the air that baseball you brought along in case you get bored of all the space travel. And measure the time it'll take the ball to hit the surface. If on Earth, the ball will fall at a speed of 32,174 feet per second. On Jupiter, the same ball will hit the ground at a speed 2.5 times greater than that. That's because Jupiter is more than 10 times as large as Earth and around 300 times as heavy as our blue planet. Now, if you move your spaceship just a little bit to the side, to one of Jupiter's moons, Europa, the situation will be completely different. Throwing a baseball in the air on Europa will mean never seeing it again. Gravity there is almost non-existent, which means that not only a baseball, but even a grown-up person can fly away any second. Now, on the other hand, if you decided to venture out of the spacecraft to explore Europa's gravitational field, why not try to lift the space vehicle itself? On Europa, a regular Earthling can easily lift up to 1,000 pounds, which is the equivalent of a full-size male moose. Or you can lift a pyramid-like formation of 9 regular people. The choice is yours. When approaching Saturn, be careful. While from afar, Saturn's rings look smooth and solid. From up close, you'll notice that they're made of chunks of ice and rocks floating in space. You won't want to have your spacecraft anywhere near those. There's also no solid surface on Saturn, which makes landing impossible. And the atmosphere is full of ammonia. Keep in mind that it's a pretty inhospitable environment for a human. Now, inside the spaceship, you find a collection of sci-fi books, enough to fill an entire bookshelf. Altogether, they must weigh around 400 pounds. Yep, that many books. And like someone with a superpower, you try to lift over 200 pounds of weight at a time. But guess what? You fail, because Saturn's gravity is too similar to that on Earth. Now, in case you got confused with all this gravity talk, when we're measuring gravity, we're speaking about the power of the force by which a planet or other space body pulls objects toward its center. So, if you need some help in organizing that sci-fi collection in alphabetical order, ask the crew to move the spaceship to a neighboring space body with a weaker gravitational pull, like Pluto. These days, it's not considered a planet anymore, just a dwarf planet and one of the furthest from the Sun's space bodies. You'll need an extra warm spacesuit to wear there. Pluto is freezing cold and has a tiny surface. It's smaller than Earth's moon. But it's a great place to test your strength. If on Earth it's kind of impossible for a regular person to lift an elephant, on Pluto you'll be able to pick up a baby elephant weighing around 265 pounds. Or even a medium-sized elephant that can be as heavy as 2,000 pounds. On your way back to Earth, you make a pit stop on Uranus. The coldest planet in our solar system has an average temperature of around minus 350 degrees Fahrenheit. So, if you attempt to get out of the spacecraft, you'll freeze mid-movement. Although gravity on Uranus is pretty similar to that on Earth, there's one thing that's very different: time. A 2-week getaway on Earth turns into a 3-year-long vacation on Uranus. Now, when you get sick of cold planets, you can travel back to warmer ones. Okay, now, Mars is definitely warmer than Uranus, but its average temperature is still about minus 81 degrees. On Earth, we only have such low temperatures at the South Pole during the winter. When you land on Mars, you'll start to feel light and strong at the same time. Mars's gravity is about 2.5 times weaker than that on Earth. So, in other words, you'll probably manage to lift your own body weight without any difficulty. So, all those handstands you've been dreaming of doing, you've found a place to fulfill your dream.